essentially, I guess the question you're asking is, what is resistance?
Yes.
And when we're talking about electrical resistance here. And essentially, at a conceptual level, and I know it's not very satisfying, but it is sort of resistance to electrical current flow. So at a conceptual level, it's how much, if you like, how hard it is to get electricity to flow through a substance at a sort of very basic conceptual level. So if you think of resistance, in sort of dynamics, which is a topic we've done before, if you're trying to move through air,
Yeah.
it's not that hard in comparison, right? But if you try to move through water at the same speed, it's a lot harder because there's a lot more resistance
Yeah.
because you've changed from air to water. So in sort of motion, that sort of resistance, fluid resistance, um, is the sort of idea. It's hard to move through. It's giving you more force backwards. Well, electrical resistance is sort of the same concept conceptually. It's the idea that if you're trying to get electricity to move through a substance, it's going to encounter some sort of resistance. Some substances will allow electricity to flow through more easily, sort of like air, us moving through air. And some will, I suppose, be harder to move through, like water for us, moving through water is harder. And so some substances will find it harder to pass electricity or electrical current. And, some will basically just won't pass. So if you put someone in concrete, they just can't run through that. They just stop completely,
Yeah.
right? So that's the basic idea of what resistance is. But of course, in science, we kind of want a quantitative idea of what resistance is. So basically, we found that, think about it this way. If you are having difficulty moving through water, right?
Yes.
If someone is trying to move through water, and I know it's not perfect, but think about it this way. If someone is trying to move through water and they're struggling, how do you get them to move faster through water? What will they need to do to move faster through water?
Increase the frequency.
Not the well,
I mean,
not so much the frequency. And you're thinking about it in terms of steps. Don't worry about that. Think about it in terms of dynamics, right? If they want to move through the water faster,
increase the force.
yeah, increase the force. Exactly. Yeah, I know you're thinking about it in terms of steps and increase the frequency of steps, but essentially, dynamics, that's going to translate to force, right? So in a physical situation, which is not a perfect analogy, you would want to increase the force. So in the case of electricity, you would increase the amount of current, which is sort of the the electricity flowing. You want to increase the force on the electrons. Does that make sense?
Yes.
You want to give the electrons more force so that they have more ability to move through. And if you like, resistance is kind of, in a way, not perfect, but kind of like the force pushing back, right? So you want to increase the force on the electron, and that technically is, electromotive force, which is not perfect, but you can think of it as voltage.
Yeah.
So what we're really saying then is, just like if you have high resistance to move through more, you need to put in more force. With electrical resistance, to get more current flowing through, you need to increase the voltage.
Yeah.
So the general idea is, to increase current, you increase voltage. That's the general idea for the things you're studying right now. Does that make sense?
Yeah.
Okay then. So that means then that the voltage and current are going to be, well, I guess, proportional to each other, right? I mean, they're going to be they're going to have a positive relationship with each other, right?
Yes.
If you increase voltage, you're going to increase current. And so that's why when they do experiments with certain sort of resistors and things like that, and you graph, usually we graph V on the vertical axis. There is a reason for that in a moment. So as you increase voltage, the current goes up, right?
Yes.
And you'll get some sort of graph that, you know, won't perfectly look like this, but you'll get something theoretically anyway like this. I mean, in practice, as you know from your experiments, you're going to get a whole lot of data points, but hopefully it sort of roughly follows this line. Does that make sense?
Yeah.
So when we graph V against I, you know, because of what we expected, as V goes up, I will go up. We get a, you know, positive relationship, positive correlation. And we basically say that it's basically like a straight line. And we, you know, we draw a line of best fit. Does that make sense? And we get this line, right?
Yeah.
This is your voltage against current graph. And how do I work out the gradient of this line?
So voltage divided by current.
Right. And because they go from 0, 0, it's essentially the total voltage over the current. And this is the slope of the line, right? This is the gradient of the line.
Yeah.
But think of what this line means. It's telling you how many volts you need to increase the current by 1 amp, right?
Yeah.
Because the steeper the line, the more volts you need for 1 amp. The smaller the less, more shallow the line, right? If I have a blue line versus a red line, you can see, like, for the same amount of current at this point here, let's say 1 amp. If it's blue, I'm going to need a low voltage. If it's black, I'm going to need a moderate voltage. If it's red, I'm going to need a high voltage to do that, right?
Yeah.
So basically the gradient essentially represents how much voltage I need to increase the current by a certain amount, such as 1 amp. Yeah?
Yeah.
Now, if you need to increase the voltage by a lot, is that high or low resistance?
It's high resistance.
If you only need to increase the voltage by a little amount, is that high or low resistance?
Low.
And so by definition, we're saying that resistance is voltage divided by current.
Yeah.
Essentially, at least with these things here, we're saying the ratio between voltage and current is resistance, and this is therefore called Ohm's law. Now, not everything follows Ohm's law, but for the things you're studying, resistors in particular, light bulbs, essentially consider that, you know, the questions you get, consider that they follow Ohm's law.
Yeah.
So in answer to your question about your sort of VI graph and resistance, essentially your VI graph is a graph that graphs voltage against current, and the slope of that graph represents resistance.
Yeah.
And that's basically that.
So how to like judge if so if a line is a resistor ohmic or non-ohmic?
Well, if it's not a straight line, it's non-ohmic,
Oh, okay.
because, you know, it's meant to be constant, right? So V equals IR, where R is meant to be constant. So, you know, for example, if I had something that looked very clearly like this, right? Then this is non-ohmic. If I had, for example, something like this, that's non-ohmic.
Yeah.
If I had something that was like this, That's not ohmic. I mean, maybe you can argue it's ohmic during this section, sort of. But the point is, ideally, it's a straight line. That means it's ohmic because V equals I is a constant. Anything else other than a straight line, technically is non-ohmic. You can argue, for example, in the blue one, it's ohmic during this section. Maybe you can argue for the black one, it's close to ohmic in this section, but not after. Maybe for the red one, you can argue it's sort of ohmic here or something like that. But the fact is, you want it to be a straight line for it to be ohmic. If it's not a straight line, it's not ohmic. And I don't think you'll get anything sort of, I think the examples they give you should be very clear cut. Either it looks very much like a straight line or not like a straight line at all.
Yeah.
In real life, you know, things are more complicated and you might be trying to make it ohmic over a particular section or anything like that. But basically, to answer your questions that you're likely to come across, you get a VI graph, look at it as if it's a straight line. If it is, ohmic. If it's not a straight line, non-ohmic.
Yeah.